Good evening. This is Professor David J. De Los Reyes. It's December 28, 2022. It's almost New Year. Okay, my topic for tonight, this will be lesson number 42 under the subject matter differential equation. I am almost done with the subject matter differential equation. Maybe after this, I will be discussing some application problems of second order differential equation. And to announce it for tonight, my next main topic will be advanced mathematics. That is the highest mathematics after the so-called differential equation. Advanced mathematics will be the next one. Okay, let's proceed. The topic for tonight is lesson number 42 and the subject matter differential equation. So this is DE 42, number 42. The title of the topic is Special Second Order Differential Equation. This should be example number, is it number 4 or number 5? I think this is number 5. Okay. So I am now completing the different topics on the second order differential equation because we are through with the 3 cases, okay? And for the last 2 days, I have discussed special second order differential equation before we will proceed maybe with the application problems. So at least we know the significance of differential equation. Okay, let's proceed with the problem for tonight. Okay, I will check my camera. Okay, let's try to bring out another problem for tonight. Special second order differential equation. Okay, I will try to read the given problem. The given differential equation is special. It's not equivalent to the first 3 cases. The given differential equation is the derivative with respect to x of open bracket x dy dx plus the quantity x plus 1 multiplied by y close bracket equal to 12. Quantity is something like this, so bracket will be the bigger one, okay? So you might be laughing when I say quantity on the bracket. Okay? It's the same, it's just a signs of grouping. Okay, the given initial condition is y equal to 0 when y prime is equal to 0 and x is equal to 1. We are given y prime over here. Y prime is actually dy dx. The meaning of this, when y prime is equal to 0, it is the same as when dy dx is equal to 0. Because y prime is the first derivative of y with respect to x for this given example. Okay, the requirement of the problem is find the particular solution. Why particular solution? We are given 3 initial conditions and supposed to be we could solve for the resulting constant of integrations. There will be 2 constant of integrations. Since this is second order, okay, there should be a K1 after the first integration and there should be a K2 after the second integration. To solve for the particular solution, we must have to solve for K1 and K2 given these initial conditions here. Okay, let's proceed with the solution. It's a little bit long, so I will try to expedite or I will make my explanation just concise, no more magic. Okay, let's proceed with the solution. If I will try to rewrite the given differential equation, I will now remove this dx over here. Okay, I will place it here. Okay, so what comes out will be the differential of the open bracket x dy dx. I'm just repeating this one, plus the quantity x plus 1 multiplied by y equal to 2 dx. I just transpose this dx here on the right, okay? Or if you don't want that one, I will just place the x over here then I will try to multiply all the terms by dx. So the left hand side multiplied by dx, this cancels, right? That will come out. The right hand side will just be simply 12dx. This is 12dx. Oh, that is just an algebraic manipulation. Integrating both sides, the integral of the differential of the open bracket x dy dx plus the quantity x plus 1 multiplied by y close bracket equal to the integral of 12 dx. Left hand side, when the integral sign goes near this differential sign, they will try to cancel out each other. So what comes out on the left hand side will just be simply the one inside the bracket, x dy dx plus the quantity x plus 1 multiplied by y equal to the right hand side. It's an easy money. The integral of 12 dx should be 12. The integral of dx is just x plus q1. Then I place it here because later on we will be placing the initial condition. I place it here. Dy dx is actually y prime. So actually I could replace this dy dx here by y prime. So I am now given this equation here. Oh, this is a part of the partial general solution. Why partial? Because we still got dy dx and the value k1. But since we are given initial conditions, we could now compute for k1. So applying the given initial condition y equals 0, when y prime is equal to 0 and x equal to 1, back here, we sorry for that one, we can compute for k1. Sorry for that one. So 1 times 0, I'm following this, times the quantity 1 plus 1 times 0 equal to 12 times 1 plus k1. 1 times 0 is 0, 1 plus 1 is 2, 2 times 0 will be 0, so this is 0. Right? So actually the left hand side is 0. Then we can compute for k1 now. k1, we transpose, then we rearrange. k1 now will be negative 12. So the resulting partial general solution is actually this. It is not yet the solution because it still contains dy dx, because the problem is asking for y as a function of x. Right? The particular solution. So to solve for y as a function of x, we must have to integrate this one again. Okay? And if we try to rearrange this one, we will divide all terms by x. Okay? On the first one, it will just become dy dx. Second one, it will be x plus 1 over x times y equal to, the right hand side, I factor out 12. Because 12 times the quantity x minus 1 is actually 12x minus 12, right? I bring out 12. What remains inside is x minus 1. We divide that again by x. So this is over x. So the resulting differential equation after the division of x is this. And if you try to recall one of the first order differential equations, this falls under the so-called differential equation solvable by using integrating factor. So I place it here. The resulting differential equation is similar to the form dy dx plus p of x multiplied by y equal to e cube x. Then by comparison, we could say that p of x is actually the ratio x plus 1 over x. So I place it here. P of x is the quantity x plus 1 all over x. Okay, I will check my camera again. Still okay? Okay. And the integrating factor for this case here is actually e to the integral of p of x dx. So this should be equal to e to the integral x plus 1 over x times dx. Two numerators all over one denominator, we could distribute it, right? So x over x is actually 1, times dx, that will just be simply dx. And 1 over x times dx is actually dx over x. Okay? So this should be equal to the integral of dx. Okay, the integral of dx, this will cancel out. It will just be simply e to the x. And the integral of dx over x, it falls under the natural logarithm, right? The value of u underneath is x, du is equal to dx, it is exact, and this falls under natural logarithm. So this is multiplied by plus the natural log of x. What comes out here is this is plus natural log of x, right? So it becomes like this. So the one you're solving under SAT, this now falls under the so-called laws of exponents, meaning same base raised to a sum of exponent can be written as SAT exam, okay? Short videos. It can be written as e to the x times e to the natural log of x. If we try to compress this one here, the compression is this. But if we try to expand this one, this should be the expansion. That is laws of exponent, SAT short videos. Okay? And e to the natural logarithm of x is actually e raised to the natural logarithm of x is 1. Meaning the antilog of the natural logarithm of x is equal to 1. Okay? So what will come out? E to the natural log of x will just be simply x times e to the x. So the resulting integrating factor is the product x times e to the x. Okay? If we now try to bring out the general solution for differential equation under first order, solvable by using integrating factor, it will be y. Why? Why? This is dy dx. Right? Times the integrating factor equal to the integral of q of x times the integrating factor multiplied with x. It is now just a matter of substitution. So what will come out? Y. The integrating factor is x e to the x. So this is y, x e to the x equal to the integral right hand side. What is q of x? Q of x is actually 12 times the quantity x minus 1 over x times the computed value of the integrating factor x e to the x times the x. And luckily, this x here cancel with this. So it now becomes simpler. So if we try to expand the right hand side, the left hand side we are good. Xy e to the x equal to, this should be 12, a common factor 12, right? 12. The product of x times e to the x is actually x times e to the x dx. I now, what do you call this, expanded. The second part is actually 1 times e to the x. This is minus 12. It's still got a 12 constant, right? The integral of e to the x dx. This is okay now, right? This is easily integrable, but for this one, we must have to bring out the solution of this separately. Okay, so the writing on the board will be minimized. So I will try to bring out the solution of this separately. So I put it on another line. I let 12 the integral of x e to the x dx equal to this portion here. Okay, I bring out the solution separately. Okay, this should be equal to ub minus the integral of b du, and this is actually integration by parts. Meaning, to integrate this one, you use integration by parts, and the formula on how to take the integral of integration by parts is actually ub minus the integral of b du. But what is u? Choose your u. From this, I could choose u to be x. So if u is x, du will be dx, right? So if u is x, the resulting e to the x dx should be dv, right? So I place it here, dv should be e to the x dx. And what is b? To compute for b, integrate both sides. Sorry for that one, my alarm goes off. It is set at 12 o'clock. Oh, okay. Integrate both sides. The integral of the differential of b is just b, and the integral of e to the x dx, easy money. Exact. The value of u is x, right? du is equal to dx. It is exact. And the integral of e to du is actually e to du plus c. So the value of b is actually e to the x. So if we now try to go back to this, 12 the integral of x e to the x dx equal to 12. Why 12? Why 12? I make a shortcut on this one. This should be equal to, I place it there. I will follow this, right? 12 times. If I will try to integrate this one, I will follow this. What is u? It is x. And what is b? E to the x. Okay? Minus the integral of b du. What is the integral of b du? What is b? E to the x. And what is du? It is dx. Okay? I will now try to simplify this one. The integral of e to the x dx is just simply e to the x. It is this. Right? So if we now try to bring out, continue the solution, okay, we'll go back here. I will follow this. This is xy e to the x equal to the integral of this one here is actually this. I expand already. 12x e to the x minus 12 e to the x. The integral of this is minus 12 e to the x. This is the one I'm telling you that it is readily integrable, except for this one, plus k2. So combining like terms, this is 12 and 12. So this is 24 e to the x. Okay? So this is now the resulting partial general solution. Why partial? The value of k2 is not known for the meantime. Okay? So to compute for the particular solution, we apply the condition y is equal to 0 when x equal to 1 and y prime is equal to 0. But there is no more y prime here, so we will just substitute the value y equal to 0 and x equal to 1. Okay? So this is, I'm following this. I will be substituting 1 times 0 times e to the 1. I'm substituting the value of x and y, okay? Equal to 12 times 1 times e to the 1 minus 24 e to the 1 plus k2. If you try to notice it, the left hand side is 0, right? Because this is 0. E is actually 2.72 something times 0, this will become 0. Right? Equal to, this is 12e minus 24e is minus 12e. So k2 now, sorry for this one, this is minus, this should be plus. Okay? This should be plus. Because 12 minus 24 is actually negative 12, and so we are solving for k2. If we transpose this one to the left, then we try to rearrange, k2 will be 12e. Okay? So if we now try to substitute this k2 here, back here, we can now compute for the particular solution. So I will repeat this one, xy e to the x, 12x e to the x, minus 24 e to the x. Okay? What is k2? This is supposed to be plus 12. Okay? Then, if I will leave the left-hand side, the remaining term will only be y. I will try to remove this x e to the x. So, if I will try to multiply all the terms by the reciprocal, that is 1 over x e to the x. For the left-hand side, what will remain will just be simply y. So, that's now y. 12 all over this will be gone. It is 12. Okay? 24 e to the x divided by 1 over x e to the x this e to the x will be gone, okay? But what will remain on the denominator will be x. Okay, this is 24 over x. And for the third part, this should be plus. It is 12 over x times the quantity e to the raised to 1 minus x. Because there is an e over here, I will try to show you. 12 e to the first all over x times e to the plus x. If I will try to place this one on top, this should become e to the negative x, right? So what will remain will be 12 over x, e raised to same base, add the exponent, so 1 minus x. So this is 12 over x times the value e raised to 1 minus x. That's the final particular solution. Actually, you can give this one now as your solution here after placing kilo, but since there are some common terms, we try to eliminate the common terms to make the particular solution simpler. So the resulting particular solution is y equal to 12 minus 24 over x plus 12 over x times the quantity times e raised to 1 minus x. Oh, that's it, guys. So it seems we solve the second order differential equation, then we go back to first order differential equation, and unluckily it falls under the so-called solution by using integrating factor. So that is a special case of second order differential equation. Same as the last example. The only difference is that for this, we are asked the particular solution because we are given the initial condition y equal to 0 when y prime is equal to 0, same as dy dx, and when x is equal to 1. That's it, guys. My next topic may be 1 or 2 or 3. I will be presenting example, application problems that involve second order. Then that's it for the differential equation. So my next topic will be advanced mathematics. That's a complete course also. Okay. So for those people who are taking differential equation, this is for you guys. If you like it, please click like. If you want to subscribe to it, please click subscribe. My YouTube channel is actually at youtube.com/@ProfDavidJ. Okay, and if you want to share it, if you're generous, you could share it to your friends or online. Okay, good evening, Los Angeles, December 28, 2022.